Hello, everybody. Once again, I am here with you for the new session. And in the previous session, we have seen that is the your classical theory of heat capacity, and in which we have seen Dulong-Petit's law that was to be related with that whatever be the vibrational energy it was to be there, it is independent of the temperature and the frequencies to be there. And somehow Einstein rejected this particularly assumption, and he invented, or he has given new theory which is related with the quantum theory, using this quantum theory, and somehow it is called to be as an Einstein theory of lattice heat capacity. So what exactly his assumption was to be there, and what was his consideration, and what he concluded, that we will see in detail. So what exactly he assumed as far as the classical theory is going to be concerned? In this case, he somehow Einstein basically applied all the things whatever the classical theory already assumed, but somehow the theory is little bit based with the quantum theory and some quantum harmonic oscillator. And here is the basic difference as far as the classical and the quantum theories are to be also there. As far as we are also aware about that, wherever in general today, that whatever be the bigger bodies are to be there, we can say it is related with the classical theory, or the classical laws are going to be applied or utilized, or somehow we can see the practically the proved that what exactly the classical laws are to be there, that is classical theory is applicable for the bigger bodies and moving bodies. As far as the smaller parts or particles are to be there, that is atom, electrons are going to be concerned, where the quantum theory is going to be implemented, and the quantum laws are not going to be applicable in the classical, and the classical laws are not going to be implemented in the somehow applicable in the particularly in the quantum. So a little bit Einstein, what he suggested, or what he considered, the little bit similar what the applied first thing, that is to be he applied the quantum harmonic oscillator is going to be there. Atoms in the crystal regarded as an identical and independent harmonic oscillator. It is similar way what exactly the classical assumption was to be there. And n number of atoms in the solids are nothing but to be equal to the 3n one dimensional harmonic oscillator. That is to be 3n, that is n is supposed to be in one dimensional atoms, and into 3n one dimensional harmonic oscillator, total n number of atoms in the solids we can say. As again all the oscillator vibrates with the same natural frequencies to be there, like this omega 0. Oscillators are here taken to be as an quantum oscillators, and have the discrete energy spectrum is to be there, not the continuous spectrum is to be there. It is the discrete the whatever be the spectrum is going to be formed, it is in the discrete, that is cut shops are to be there. So it is one another thing what exactly the considerations. Any number of oscillators may be present in the same quantum states are to be there. This is one of the part. And atomic oscillators from an assembly of the system that obeys the Maxwell's Boltzmann distribution, that is to be another one part, which is to be as an Maxwell's Boltzmann distribution of the energy is going to be utilized for calculating the total amount of energy in this case, or in this particularly using the Einstein theory is to be there. So these are the somehow considerations are to be there. And here what exactly the Einstein's theory is to be there. Now considering the Planck's quantum theory, that is to be as in discrete energy values for of an oscillator with the frequency is to be as in here Planck's quantum, that is to be h mu quantum quanta is going to be there, and mu is nothing but to be frequency. Here the part here mu is nothing but to be, this one is to be there. So this is nu are nothing but to be considered to be as an frequency. H nu is nothing but to be, we can say, as an photon quanta is to be there. And always we can say the light is always in the quanta, and that's what to be the word h mu. And here epsilon is nothing but to be n h mu, that is n h cross omega 0, where it is comes from the h upon twice pi is nothing but to be the h cross, and omega 0 is nothing but to be the, where if you see in detail, 0 1 2 3 is called as a quantum numbers, and Einstein later used this as an technical point of view, the wave mechanical results, which gives the energy levels of the harmonic oscillators. And epsilon is nothing but to be the particularly as an inner what you have energy as far as these part is or the this quantum theory are going to be utilized in this. So epsilon is nothing but to be given with the n plus half h cross omega 0, that is included that n plus half into h mu, that is converted into the n plus 1 half into h cross omega 0 is to be there. This is somehow the where the half h cross omega 0 is the temperature independent 0 point energy contribution to the internal energy of the oscillator. It means that what Einstein suggested, whether the external any temperature or the frequency you are giving or not, that doesn't matter to be, but still there is a vibrational energy already as far as 0 degree, means as far as why these temperature related things are to be there, because wherever we can say the specific heat of the solid or the heat capacity, lattice heat capacity, we know that degree 1 degree increasing the temperature for 1 gram of mass of the molecules are to be there, the whatever be the temperature you are raising from 1 degree, that is somehow giving you the specific heat. And as far as the specific heat of the solids are going to be concerned, it is specific heat at the constant volume is we are going to be considering. Now in this case, either I am going to be increasing the temperature through 1 degree or 0 degree temperature is to be there, still there is energy in that crystal or the solid is to be there. That is what the quite interesting Einstein theory is to be there, and that's why he included this term, that is half h cross omega 0 is the temperature independent 0 point, means either you are giving temperature to that particular crystal or the solid, it doesn't matter, but still there is energy. And how much amount of energy is to be there? It is half h cross omega 0 temperature independent. That is why it is called 0 point energy, because where you are giving the temperature or not, that doesn't matter, either you are not giving the temperature, still energy is there in that crystal or the lattice is to be there. And that's why either you are not giving the temperature, that means 0 degree, that means 0 point energy it is called, and it is half h cross omega 0 is to be there. And that is what the contribution is to be there. And when I am going to calculate the energy, I have to take Maxwell's Boltzmann distribution is to be there. And in this case, the internal energy increasing, that is to calculate the average energy of an oscillator, we replace the expression for the Boltzmann distribution or Maxwell's Boltzmann distribution energy, and it is somehow given with this relationship. And a little bit I will shift myself here so that will easy to understand. Now look at this case where I want to focus. This is what the average energy by the Maxwell's Boltzmann distribution energy, distribution of energy is to be there. If you look at this average energy, that's why epsilon bar is given, it is to be here. And somehow it is to be again uh, summation is going to be used. That's what again I will explain why this summation instead of this integration is to be there. Summation is sum of, that's why somewhere it is going to be fixing the number of atoms inside the particular one dimensional or the whatever be the crystal you are taken into account. And that's why the integration is replaced by the summation, and summation is from the n is equal to 0 to infinity. So infinity word is nothing but to be here unpredicted, that is infinity means we don't know exactly how much number is to be, that's why it is given to be as an n is equal to 0 to infinity, summation of, and epsilon exponential of minus of epsilon upon kbt divided by summation of n is equal to 0 to infinity exponential of minus of epsilon upon kbt is to be there. This is what the Maxwell's Boltzmann distribution formula, and here the summation is going to be used for summing all the amount of energy or all amount of atoms whatever it is to be there and how much amount of energy is to be there, that we want to calculate. So this is what the general expression, and when we are placing this relationship, that is what we have seen in the previous equation, that is epsilon n is equal to n plus this one is to be there at this epsilon n. This is what the n plus half into h cross omega 0 is to be there. So when we are putting this relationship to be in this Boltzmann distribution average energy relationship, then we will get the new relation, and that new relation is nothing but to be given here. It is in this fashion, and it is nothing but to be epsilon bar is equal to summation of n is equal to 0 to infinity in bracket n plus half into h cross omega 0 exponential of minus of n plus 1 n plus half into h cross omega 0 by kbt divided by summation of n is equal to 0 to infinity exponential of minus of n plus half h cross omega 0 kbt is to be there. So here this is what the epsilon n value is going to be putting here in this relation, and we will get the new relation likewise this. Now here by kbt is to be likewise this h cross omega 0 en, that what we have put here, and divided by kbt is to be there. Similar way, divided by summation of n is equal to 0 to infinity exponential of same thing is going to be placed here, just we are replacing that relationship. Now here if we are moving forward, if we are putting these relationships, and we are when we are going to calculate the every time h cross omega 0 by kbt will be larger to put this value. For that we are what putting this as an x, that's why minus of x is nothing but to be here minus of h cross omega 0 by kbt. When we are replacing this with the value, then we will get the particularly relationship to be as an likewise this, and it will give me h cross omega 0 summation of n is equal to 0 to infinity n plus 1 n plus half exponential of again in bracket n plus half x is to be there, and here again to be as an basically exponential of n is equal to 0 to infinity summation of exponential of it is to be n plus half into x is to be there. So x is nothing but to be minus of basically h cross omega 0 by kbt is to be there. So this is what the relationship is going to be there as far as this part, as in your exponential this x factor is taken into account there. It is to be as an this relationship is to be here. If you will find this h cross omega 0 हे ह्या इक्वेशन मध्ये इथं जे h क्रॉस ओमेगा 0 आहे हे इथं बाहेर घेतलेलं आहे, आणि म्हणून कन्फ्यूज व्हायचं काम नाही की हा h क्रॉस ओमेगा 0 इथला गेला कुठे. सो कॉन्स्टंट इज टेकन इनटू आउटसाइड, आणि म्हणून इथं जे आहे ह्या h क्रॉस ओमेगा 0 बाय kbt ला x ने आपण रिप्लेस केलेलं आहे. सो दिस इज व्हॉट द न्यू रिलेशन इज गोइंग टू बी फॉर्म. फॉर द सिम्प्लिफिकेशनला अवघड होऊ नये म्हणून आपण त्याला सिम्पली एक्स तिथं रिप्रेझेंट केलं मायनस ऑफ. आता ह्या पद्धतीने ज्यावेळेस आपण व्हॅल्यूज इथं पुटअप केल्या आणि त्यानुसार सॉरी इथं जेव्हा एक्सला रिप्लेस करून ह्यानुसार लिहिलं, आता एनच्या व्हॅल्यूज जर मी पुटअप करत गेलो आणि टोटल एनर्जी कॅल्क्युलेट करायचं जर ठरवलं, तर एन इज इक्वल टू जर फर्स्ट अमाऊंट आपण समजा 0 घेतलं तर दिस विल बिकम 0 प्लस हाफ, म्हणजे हे होईल 1/2. जेव्हा एन इज इक्वल टू 0 व्हॅल्यू पुटअप करायलो हे होईल that is to be 0 plus 1/2. So it is simply giving me the new relation. If you look at this case where the h cross omega 0 already मी इथं बाहेरच ठेवलेला आहे, हा h cross omega 0 ऑलरेडी बाहेर आहे, पण याच्यामध्ये काय होते दॅट इज हाऊ इट इज n इज इक्वल टू ज्या वेळेस मी 0 ठेवायलो हा 0 झाला, हा n 0 झाला, हा सुद्धा n इथं 0 होईल. मग 0 प्लस 1/2 म्हणजे इथं राहणार फक्त काय 1/2 एक्सपोनेन्शियल ऑफ 0 प्लस 1/2 म्हणजेच 1/2 इंटू एक्स, म्हणजे एक्सपोनेन्शियल ऑफ काय होणार आहे 1/2 एक्स किंवा x/2 सिम्पल वे असंही म्हणू शकतो मी. आणि एक्सपोनेन्शियल जसं 1x/2 म्हणालो तसंच एक्सपोनेन्शियल मला असं पण लिहिता येते एक्सपोनेन्शियल ऑफ x/2, याचाही अर्थ तोच होतो जो की इथं एक्सपोनेन्शियल अशा फॉर्ममध्ये लिहिलेलं आहे. मला असंही लिहिता येतं आणि असंही लिहिता येतं. म्हणून मग इन ब्रॅकेटमध्ये एच क्रॉस ओमेगा 0 इन ब्रॅकेटमध्ये काय राहील? इन ब्रॅकेटमध्ये राहील हाफ एक्सपोनेन्शियल ऑफ एक्स बाय 2. मग त्यालाच मी काय लिहिलं? यानुसार असं लिहिलं. सो लुक ॲट दिस केस, हाफ इंटू एक्सपोनेन्शियल ऑफ एक्स बाय 2. जेव्हा एन इज इक्वल टू 0 पुटअप करायलो, पण ज्या वेळेस एन इज इक्वल टू 1 पुटअप करायलो काय होते? फक्त वरचा पार्ट सध्या बघूया. सो आता ह्या ठिकाणी एन इज इक्वल टू जर 1 ठेवलं तर धेअर इट इज टू बी 1. हा एन सुद्धा इथं 1 प्लस 1/2 दॅट इज बे एक बे आणि 3 इज टू बी देअर. मग 3/2 एक्सपोनेन्शियल ऑफ म्हणजे 3/2 इथं होईल 3/2 आणि इंटू काय? एक्सपोनेन्शियल ऑफ अगेन टू बी ॲज एन इथं काय होणार आहे? 1 प्लस 1/2 म्हणजे 3/2 एक्स म्हणजे 3x/2 असं मला लिहिता येतं. मग जेव्हा n इज इक्वल टू 1 पुटअप करायलो, इट इज 3/2 एक्सपोनेन्शियल ऑफ 3x/2 इज टू बी देअर. सिमिलर वे पुन्हा जेव्हा मी 2 ठेवतो, इट विल बिकम 5/2 एक्सपोनेन्शियल ऑफ 5x/2 प्लस सो अँड सो 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 सो. सिमिलरली जर समजा खाली बघताल तर डिव्हायडेड बाय जी आपण घेतलेलं आहे एक्सपोनेन्शियल ऑफ n प्लस 1/2 एक्स. मग ज्या वेळेस मी इथं समजा 0 ठेवायलो, इट विल बिकम एक्सपोनेन्शियल ऑफ x/2 आणि जेव्हा 1 ठेवाल इट इज 3x/2, जेव्हा 2 ठेवाल 5x/2. सो इन दॅट केस दिस रिलेशनशिप विल बिकम लाईकवाईज दिस. सो अशा पद्धतीने हे रिलेशन ह्या पद्धतीने बनेल. सो दिस विल बी बिकमिंग टू बी ॲज एन दिस पार्ट. अशा पद्धतीचं हे नवीन रिलेशन ॲव्हरेज एनर्जीचं ॲप्सिलॉन बार साठी बनेल. आता जर समजा ह्याच्यामध्ये मी लिमिट इम्प्लिमेंट केलं समेशन काढून, सो एच क्रॉस ओमेगा 0 ddx ऑफ लॉग ऑफ एक्सपोनेन्शियल ऑफ x/2 प्लस एक्सपोनेन्शियल ऑफ 3x/2 प्लस एक्सपोनेन्शियल ऑफ 5x/2. I can say this is somehow I can write in the another format. It is in the similar way I can write it is implemented in this fashion, then it can be written in the log of form. It is nothing but to be likewise this log of form मध्ये मला अशा पद्धतीने मिळेल. सो एच क्रॉस ओमेगा 0 ddx ऑफ लॉग ऑफ एक्सपोनेन्शियल ऑफ ह्याच्यामधून जर समजा एक्सपोनेन्शियल ऑफ x/2 जर कॉमन काढलं तर मग इथं काय उरणार आहे? इथं 1 प्लस कारण एक आलं ना इथला हा प्लस 1 प्लस एक्सपोनेन्शियल ऑफ 3x/2 आहे. आपण मी बाहेर काय काढलं आहे? एक्सपोनेन्शियल ऑफ x/2 काढलेलं आहे. मग इथं उरलं कोण? इथं जर समजा 3x/2 मधून 1x/2 जर मी काढला तर 2x/2 म्हणजेच 2x/2 म्हणजेच x. 2 कॅन्सल होईल आणि x उरल, म्हणून इथं एक्सपोनेन्शियल ऑफ x. मग तसंच जर समजा 5x/2 मधून जर समजा मी मायनस केलं तुमचं x/2 तर काय उरते? 4x/2 म्हणजेच 4x/2 म्हणजे काय? बे दोन्ही 4 म्हणजेच 2x, म्हणून एक्सपोनेन्शियल ऑफ 2x प्लस सो अँड सो. मग अशा पद्धतीने नवीन रिलेशन बनेल. पण लॉगमध्ये एक रिलेशनशिप आहे जी मला लिहिता येते 1 प्लस एक्सपोनेन्शियल ऑफ x प्लस 1 प्लस एक्सपोनेन्शियल ऑफ 2x प्लस सो अँड सो. आय कॅन राईट मायनस ऑफ लॉग ऑफ 1 मायनस एक्सपोनेन्शियल ऑफ x. हे मला सिम्प्लिफाय करता येते. आणि हेच जर समजा मी रिलेशन ह्या पद्धतीने याच्यामध्ये इम्प्लिमेंट केलं तर आय विल गेट द न्यू ॲव्हरेज व्हॅल्यू ॲव्हरेज एनर्जी value is nothing but to be epsilon bar is equal to h cross omega 0 ddx of x/2 minus of log of 1 minus exponential of x is to be there. मग ह्यालाच समजा आणखीन मी ddx जरी काढून टाकलं तर h cross omega 0 I can write to be as an half x/2 चं half plus exponential of x by 1 minus exponential of x. आता ही जी व्हॅल्यू आली ह्या व्हॅल्यूला जर समजा मी इट इज टू बी ॲज अन एच क्रॉस ओमेगा 0 ॲज इट इज हाफ ॲज इट इज मी इथपर्यंत सगळं इक्वेशन तसंच ठेवलं. पण हे जे एवढा पार्ट उरलेला आहे ह्या पार्टला जर समजा e⁻x जर मी पूर्ण ह्याला डिवाइड केलं तर काहीच रिलेशनमध्ये फरक पडत नाही. पण रिलेशनशिपमध्ये फरक पडतंय. e⁻x/2 बाय e⁻x म्हणजे झाली व्हॅल्यू 1, म्हणून इथं आलं 1. पुन्हा दुसऱ्या पार्टमध्ये मी जर समजा असं केलं की पुन्हा 1 बाय e⁻x पुन्हा e⁻x आणि हे जर वर गेला तर e⁻x म्हणून इथं e⁻x झालं. इथं मायनस e⁻x डिवायडेड बाय e⁻x दॅट इज 1 म्हणून इथं 1 झालं. म्हणून हे सिम्प्लिफाईड रिलेशन कसं येणार आहे, h क्रॉस ओमेगा 0 इंटू 1/2 प्लस 1 अपॉन एक्सपोनेन्शियल ऑफ मायनस एक्स मायनस 1 इज टू बी देअर. सो दिस इज हाऊ द न्यू रिलेशन इज टू बी बिकमिंग. आता ह्याच रिलेशनशिपला जर समजा मी एक्स जो होता, एक्सची व्हॅल्यू जी होती मायनस ऑफ एच क्रॉस ओमेगा 0 बाय के बी टी, ही जर पुटअप केली तर ही मायनस होती आणि इथं मायनस आहे, मायनस मायनस होऊन जाईल प्लस, म्हणून इथं काय होईल, एच क्रॉस ओमेगा 0 इंटू हाफ प्लस 1 अपॉन एक्सपोनेन्शियल ऑफ एच क्रॉस ओमेगा 0 बाय के बी टी मायनस 1. हे प्लस का झालं, कारण इथं ऑलरेडी मायनस आहे आणि एक्सची व्हॅल्यू मायनस ऑफ एच क्रॉस ओमेगा 0 बाय के बी टी आहे, म्हणून मायनस मायनस प्लस होते. सो दिस रिलेशनशिप विल लुक्स लाईक्स टू बी ॲज अन दिस. आता हे ह्या पद्धतीने झाल्यानंतर याच्यामध्ये जर समजा ह्या एक्सपोनेन्शियल फॉर्म जर काढला आणि दॅट विल बिकमिंग टू बी ॲज अन एच क्रॉस ओमेगा 0 जर समजा मी मल्टिप्लाय केलं तर हाफ एच क्रॉस ओमेगा 0 हा एक पार्ट, ह्याच एच क्रॉस ओमेगा 0 ह्याला मल्टिप्लाय जर केलं तर इथं एच क्रॉस ओमेगा 0 डिवायडेड बाय येते, म्हणून एच क्रॉस ओमेगा 0 डिवायडेड बाय सो अँड सो. सो दिस इज व्हॉट द व्हॅल्यू. हे एक्सपोनेन्शियलच फॉर्म आहे, ह्याला फक्त ह्या फॉर्मॅटमध्ये लिहिता येत असते. सो दिस आय कॅन राईट, हा एक्सपोनेन्शियल फॉर्म मी ह्या फॉर्ममध्ये लिहिला, एवढाच त्याच्यामधला बरोबर. So this is somehow I can write the relationship in this way. So again this equation is going to be somehow replaced in this average energy expression can be written as an epsilon bar is equal to h cross omega 0 and so and so. Why it is to be there likewise this, because it is somehow आपण आधी पण सुरुवातीला म्हणलं होतं की हाफ एच क्रॉस ओमेगा 0 ही काय 0 पॉईंट एनर्जी, म्हणजे जरी टेम्परेचर दिलं नाही तरी ह्याच्यामध्ये असणारी एनर्जी हे ह्याच्यावरून प्रूव्ह होते. म्हणजे जर समजा टी जरी 0 झाला तर दॅट विल बी कमिंग टू बी ॲज अन दिस मच ऑफ व्हॅल्यू. सो दिस एक्सप्रेशन इज समहाउ आयडेंटिकल अँड so the previous relations are to be as an identical to this new relation. The difference of this half h cross omega 0 which is to be temperature independent 0 point energy जे मी तुम्हाला आत्ताच सांगितलं आणि ती व्हॅल्यू ह्याच्यामध्ये इथं आलेली आहे. आणि जर समजा टी इज बिकमिंग टू बी 0 दिस ॲप्सुला बार विल बिकमिंग टू बी, आता जर ह्या एक्सप्रेशनमध्ये म्हणजे आधीचं जे एक्सप्रेशन आहे ह्याच्यामध्ये जर समजा टी जर 0 झाला तर ही क्वांटिटी पूर्ण 0 होऊन जाते, दिस क्वांटिटी 0 होऊन जाते आणि उरतंय काय हाफ एच क्रॉस ओमेगा 0, ॲप्सुला बार इज इक्वल टू हाफ एच क्रॉस ओमेगा 0. म्हणजेच सांगण्याचा उद्देश काय, व्हेन द टेम्परेचर इज बिकमिंग टू बी 0 दी ॲप्सुला बार ॲव्हरेज एनर्जी विल बिकमिंग टू बी ॲज अन हाफ एच क्रॉस ओमेगा 0. म्हणून आईन्स्टाईनने काय सजेस्ट केलं की ज्या वेळेस टेम्परेचरही जर नाही दिलं तर त्याच्यामध्ये काही अमाऊंट ऑफ एनर्जी असते, ओन व्हायब्रेशन त्याचं जे काय आहे ते चालूच असतं, ते जी काय एनर्जी आहे दॅट इज नथिंग बट टू बी calculated and that is half h cross omega 0 is to be there. This is what the according to the quantum mechanics to the atoms are basically somehow when moving forward the according to the quantum theories that whatever at the 0 degree temperature the atoms possesses the some sort of vibrations and that's why the vibration energy is to be half h cross omega 0. म्हणजे जरी 0 डिग्री केल्विन असलं तरी काही ना काहीतरी त्याचं ॲटमचं व्हायब्रेशन होत असते आणि ती व्हायब्रेशनमुळे त्याची एनर्जी ती किती येते हाफ एच क्रॉस ओमेगा 0. दिस एनर्जी however has an contribution to the CV specific heat at the constant volume is to be there. It may be noted that the previous expressions contains the frequency of oscillator and somehow in contrast to the corresponding expression right now whatever is to be there, which is somehow related with the your classical theories cross one, and somehow it is to be the expression for the internal energy of the crystal becomes to be as an epsilon total energy E is equal to आपण काय म्हणले 3n कॅपिटल एन ॲप्सुला बार. मग आता ही 3n म्हणजे ही वन डायमेन्शनल जसं म्हणलं इंटू 3n म्हणजे टोटल एनर्जी होणार. मग इथं जर समजा मी ह्याची व्हॅल्यू ॲप्सुला बारची व्हॅल्यू जर पुटअप केली जी आहे ती इट इज बिकमिंग टू बी हाफ एच क्रॉस ओमेगा 0 होतं, तर ही जी ॲप्सुला बारची व्हॅल्यू आहे ती जर पुटअप केली तर इट विल बिकम 3/2 कॅपिटल एन एच क्रॉस ओमेगा 0 प्लस 3n एच क्रॉस ओमेगा 0 बाय एक्सपोनेन्शियल ऑफ h cross omega 0 by kbt minus 1. This is what the some important relationship total energy. पण specific at the constant volume जर मी calculate केली तर this relation will become likewise this, that is 3n kb into h cross omega 0 by kbt square into exponential of this h cross omega 0 by kbt divided by exponential of h cross omega 0 by kbt minus 1 is to be there. So this is what the new relation at the specific heat at the constant volume is to be there अकॉर्डिंग टू आइन्स्टाईन. ह्या रिलेशनमध्ये जर समजा एच क्रॉस ओमेगा 0 बाय के बी हे जर समजा आइन्स्टाईन कॉन्स्टंट म्हणून जर घेतला, दॅट इज टू बी theta e, that is suffix e, that is nothing but to be Einstein constant is to be there. He founded or the invented, that's why this characteristics temperature known as Einstein temperature. and हे जर मी रिप्लेस केलं ह्या इक्वेशन मध्ये तर ह्या ठिकाणी ही व्हॅल्यू जी आहे इट इज बिकमिंग टू बी थिटा ई बाय टी. आणि म्हणून नवीन रिलेशन जे काही मला मिळते ते रिलेशनशिप म्हणजे सी व्ही इज इक्वल टू आय कॅन राईट ॲज ए 3n kb theta e by t whole square into exponential of theta e by t divided by exponential of theta e by t minus 1 whole square is to be there. So this is what the specificity at the constant volume as far as the Einstein is going to be concerned. पण जर समजा ह्याच्यामध्ये इथपर्यंत ठीक आहे हे एक्सप्रेशन आलं, पण जर समजा टेम्परेचर जास्त असलं आणि कमी असलं तर काय ह्याच्यामध्ये ह्या रिलेशनशिपमध्ये फरक पडते. सो for the higher temperature behavior, what we have considered, that is to be, if suppose the temperature is high, what happens, the kbt is greater than the h cross omega 0 is to be there, and t is nothing but to be greater than the theta e. Einstein's constant पेक्षा ती जर समजा सॉरी टेम्परेचर जे आहे आइन्स्टाईन टेम्परेचर त्याच्यापेक्षा जास्त जर असेल तर ही रिलेशनशिप बनते, इट इज इक्वल टू द case where it is to be becoming as an h cross omega 0 by kbt is to be there. So because of these values are to be, हे जर बघताल बेसिकली ह्या केसमध्ये इथं जे काही रिलेशनशिप आहे एक्सपोनेन्शियल ऑफ एच क्रॉस ओमेगा 0 बाय के बी टी हे minus of 1 is equal to or nearly equals to, it will become to be as an 1 plus h cross omega 0 by kbt plus so and so whatever values minus 1, it will become only relationship will be remaining to be as an greater than ज्यावेळेस आपण म्हणतो त्यावेळेस h cross omega 0 by kbt is to be the value what it is giving me. आता ह्या केसमध्ये जर समजा ही व्हॅल्यू जर पुटअप केला तर ॲव्हरेज एनर्जी इन दॅट केस विल बी कमिंग टू बी ॲज अन half h cross omega 0 plus kbt, and that is nothing but to be 0 point energy जर consider केली तर actually value will be kbt is to be there. So whatever be the values are to be, epsilon bar is going to be there, average value epsilon bar is going to be there, it is having the relationship likewise this. So at higher temperature the average vibrational energy is the same as that obtained in the classical theory. So it is average energy जी आहे हाफ आणि हाफ तशी ती टोटल के बी टी जशी मिळाली तशी क्लासिकल थेरीनुसार मिळते. आणि द रिलेशनशिप जी काय आहे स्पेसिफिकेट ॲट द कॉन्स्टंट व्हॉल्यूम, इट इज नथिंग बट टू बी गिवन विथ सी व्ही इज इक्वल टू likewise this, it is 3n kb h cross omega 0 by kbt square into 1 plus h cross omega 0 by kbt divided by h cross omega 0 by kbt whole square. This is what the new relation is specified at the constant volume. त्याला जर simplify केलं it will become to be as an 3n kb into 1 plus h cross omega 0 by kbt is to be there. For larger t the h cross omega 0 by kbt will become to be 0, and whatever be the new relation cv is nothing but to be 3n kb, and it is somehow given as a 3r, and Dulong-Petit's law it is which is to be the Dulong-Petit's law as obtained with this relationship as n is equal to na is to be there. So this is what for the higher temperature. For the lower temperature kbt is lower than this h cross omega 0. In that case exponential of h cross omega 0 by kbt minus 1 will become exponential of h cross omega 0 by kbt is to be there. आणि म्हणून नवीन रिलेशन जे काय बनणार आहे ते नवीन रिलेशन फायनल काय होणार आहे, इट इज epsilon bar is equal to half h cross omega 0 plus h cross omega 0 into exponential of minus of h cross omega 0 by kbt is to be there. and this relationship is going to be somehow again changed or simplified. At the lower temperature, the average vibrational energy decreases exponentially with the decrease in the temperature. टेम्परेचर जसं डिक्रीज व्हायला तसं त्याची व्हॅल्यू सुद्धा डिक्रीज होत जाणार, आणि एक्सप्रेशन विल बी given as a CV is equal to this much of amount, and this is somehow given with CV is equal to 3n kb into h cross omega 0 by kbt whole square exponential of h cross omega 0 by kbt is to be there. Now this becomes to be as an smaller value as the term theta e, it becomes to be जर theta e च्या फॉर्म मध्ये लिहायचं असेल तर फक्त इथं काय होईल तर theta e by t एवढंच याच्यामध्ये रिप्लेस होईल, बाकी ॲज इट इज तसंच राहील. सो फॉर द लोअर टेम्परेचर टी इज जेव्हा एक्सटर्नल टेम्परेचर हे थीटा ई पेक्षा लेस असेल त्यावेळेस द हीट कॅपॅसिटी इज प्रोपोर्शनल टू exponential of minus the theta e by t is to be there, and which is dominated factor and exponential factors to vary as n t raised to 3 for particularly this for the most of the solids are to be going to be followed. So as far as the theory it is not necessary to get the plot for that one. So this is for the lower temperature and the higher temperature, how the your Einstein temperature and your whatever be the average specified at the constant volume is going to be changing according to the Einstein theory is to be there. Majorly output of this Einstein theory was to be whether you are giving external temperature or not, there is energy, and that is 0 point energy is already there, which is half h cross omega 0 is to be there. म्हणजे तुम्ही जरी टेम्परेचर नाही दिलं तरी त्या क्रिस्टलमध्ये त्याचे व्हायब्रेशन्स चालूच असतात, त्याची व्हायब्रेशनल काही ना काहीतरी स्वतःची एनर्जी असते. आयदर यू आर गिव्हिंग सम एक्सटर्नल टेम्परेचर to the crystal, and this is how the Einstein theory was to be there. And for concluding this session, thank you, and be at home and be safe.